Hi there. Yeah, so can you hear me okay? All right. Whoa, hello. Let's get this party started with some code. This is going to be a pretty, I'm going to start off with some slides. I'm not really a big fan of slides, and we're all, I think, techies, so we like to see code. So we're going to see code in a sec. But let me just, to set up context a little bit, let me just explain what's going on here. So I can't remember the actual title of this talk. I think I made it generic so that whatever I was working on at the time, I could just show you guys what I'm working on. So, but it's all related to machine learning pipelines, and the goal for my company, Pipeline.io, is to sort of empower data scientists, you know, as silly as that sounds, but trying to give them, so my experience at like Netflix, for example, I really saw where they gave developers the power to, you know, push out our own code and to tear down clusters and spin up clusters and to update our own configurations. And it was very scary, and people get fired over this kind of thing. And I personally took down all of North American streaming for about 5 minutes because of a bad configuration change at Netflix. But that was my first month, and they didn't fire me, so that was good. So I stayed to see more configuration changes, and so I joined Databricks then a couple years later, and talking to these data science groups, I started to realize that when they would build their models within Jupyter Notebook or within Zeppelin or Python, whatever, they didn't know what to do with it after that, or they would hand it off to somebody like a production engineer who would basically hand type all the weights and things like that. So trying to kind of get rid of that role, because no one likes that role. The person doing that role that's actually updating the weights doesn't like that role. There's just not enough iteration going on, not enough experimentation in live production, right? Which is really scary to some, but with proper tooling, right? This is actually not that bad. This is something the Netflix team has a just super awesome tools team where that's their entire job, is to give us developers, give us more control. And the ability to not just push out clusters, but also scale them back down like roll back, flip them back, things like that. So, but the key there is like giving us tooling and giving us metrics, right? Like giving us dashboards, so that like we can actually see system performance if we did push out some code where the JVM was spiking, the heap size was spiking, or CPU load was spiking, things like that. So I think this is close to the title, but the key here is from the notebook straight out to microservice. And I'm actually going to show you guys Netflix microservices, which have some nice benefits to them, which I'll talk about here in a second. So thank you for having me. I think I submitted a talk last year and got lost somewhere. I think I started to submit the talk, and there was like 5,000 pages I had to fill out. There was like a PDF, and I think I like messed up part of the PDF, and it just got squashed. So I was really very happy when you contacted me. I thought I really had to read it twice to believe it. So. Also, as a nice bonus, we aren't just going to deploy to just some, probably like on-premise, or I'm not deploying to my laptop. I'm obviously deploying out to the cloud, but not just one cloud. Today we're going to actually deploy to 2 clouds. So we're going to have a hybrid deployment, cross-cloud, so hybrid cloud deployment. We're going to be using Kubernetes and Docker. We spoke about this in the panel earlier today. My view is if you're starting any project right now, start it with Docker. The specific deliverables that our company gives, because we're just research, we actually produce Docker images and make them public, and then other people can build off of them. So this has actually worked really well for us, and for people, our partners and things like that. So. I think I already explained, formerly Netflix, formerly Databricks. You can find me Pipeline.io. Actually, oh, I should do a quick plug. Saturday, I'll be at the Biva offices doing a full workshop. We're going to build an end-to-end pipeline using Spark ML and Kafka and Spark Streaming, and we'll have some fun TensorFlow in there too, just because everyone loves TensorFlow. So yeah, come check it out. You can get more details, Pipeline.io. I think we have about 25 people that are in it right now. The most I've done is 120 at once, and I give everyone their own cloud instance that's running their own Docker. So there's no contention, there's no multi-tenancy. You actually have the full box, and you have 50 gig RAM, you have 8 cores. At the very end, we put all of that like horsepower into one big Spark cluster. And yeah, I think the most we had 5 terabytes, I think, of RAM, and I don't know, 500 cores, something like that, or I think it was 800 cores, yeah. And I think there's a video of it somewhere online where we actually run through and do a bunch of matrix factorization with this big cluster, and I have everyone raise their hand when they start seeing their little Spark worker light up. It's pretty fun. Yeah, so all the code I'll be showing today is in this repo, Flux Capacitor. It's kind of a fun little pet name that I have for this project, and there's also Docker Hub. We've got quite a bit of activity even in just the last few months. We're at about 900 stars and 6,000 pulls. I'll just briefly go through. We've been brainstorming a lot, working with some of these big companies to try to come up with use cases. This is where we got the idea that I mentioned this morning in the panel where like data scientists wanted to use the same environment that they're developing in. That's what they wanted to actually deploy. And not until things like Docker for Mac, like native Docker for Mac, not that janky version that was there before, and like native Docker for Windows, and there's this technology called Minikube, which is a local version of Kubernetes. So this is super powerful because you can essentially simulate clusters on your local laptop, and then with just a couple buttons, scale that same exact cluster out into the cloud, or like hybrid cloud like we're going to show today. And you're guaranteed it has the same libraries of scikit-learn and same libraries of Flask and all that kind of stuff that you're working with locally. So this has been a pretty big year in terms of like data science empowerment. So yeah, we've been talking to people like Uber and Zynga and like Netflix, obviously, and we're starting to also see a lot of the online training, like use cases, which we cover. Actually, I'm covering that tomorrow. I think there's a 45-minute workshop tomorrow, so I'll speak to that, where we're actually going to train online. We'll generate offline batch recommendations using matrix factorization across all of the data that we have, all of the batch historical data. And then throughout the day, in an incremental fashion, we'll actually make slight little changes to those item factors and those user factor matrices, like using stochastic gradient descent with batches of data coming in every 5 seconds, things like that. It's very similar to what Netflix does. They don't do it every 5 seconds, of course, because they have a lot of data, but they do it every hour, every half day, so you're able to actually capture intraday trends, right? And then picture each night those get blown away by a complete batch, like offline, and then that process starts over. So we'll talk about that tomorrow and then also Saturday for the workshop. So yeah, this was the big thing too, is I've got my Zeppelin notebook or my Jupyter notebook, and now what do I do, right? Like how do I get this model out there? How do I get, if I want to do multiple versions, A/B testing, like multi-arm bandit, that kind of stuff. So we've been focused on model deploying and testing, of course, and scaling. And the big thing we're going to talk about today is actual model serving. So we're going to generate a decision tree within Jupyter, like using Python. We're going to take Spark, so Spark ML in Python, and then we'll convert that. So there's 2 things we'll do. We'll convert it to PMML, and then ship it to a live running server that can read the PMML, and then we'll start to load test that server and actually look at the like performance metrics on that. And yeah, we'll see the scoring comes in at about 3 or 4 milliseconds tops. So, and then the second thing we'll do is we can actually generate code. So instead of generating PMML for these decision trees, we can actually generate Java code, we can generate C code. It's, for decision trees, it's just a big if statement, right? And there's ways to do optimizations, of course, right? You can flatten parts of the tree. There's a lot of research on this stuff, but not a lot of implementations. So, and then the fourth bullet point is that code generation. The third bullet point there that I skipped is more that sort of incremental online training. So things like in scikit-learn, for example, there's this function called partial fit on some of the linear models, right? So this is very powerful. Check this out. It's an incremental training mechanism within scikit-learn. I didn't know that this existed until just a couple months ago when we started scoping out this effort. But it's not on all of the scikit-learn models, of course, but these linear models lend themselves very nicely to that. So linear regression, logistic regression, that kind of thing. Okay, so it's kind of visual here, pushing this out. So picture from the notebook, and I keep showing Zeppelin here. These slides are back when I was doing a lot more Scala Zeppelin stuff, but yeah, today we'll be using Jupyter. So picture the ability to push this out, and you have your existing cluster that has, right, like 1,000 nodes, predictive, or right, like prediction nodes that have the current model, that have that current, right, like decision tree that's been generated. So they're out there chugging away, making decisions, predicting, and now what you want to do is put one, right, like put one new instance behind that same load balancer. And so now some of the traffic goes to that new, right, like Canary instance is what we call it. And so picture showing the data scientist actually how the current cluster or that current model is doing, right, like relative to the new model. And so now you can compare and see, oh, I'm right, like wildly out of predictive. So you might want to tear down that Canary. Or if things go well and things are pretty close, or you're starting to see what you were expecting to see, you could actually scale up the Canary into its own full cluster of 1,000 and then slowly scale down the other one. Or do like a blue-green deployment where you scale up the new one and then flip the load balancer, right? So this is all just a couple commands away with Kubernetes. So that's the other thing too. Yeah, this was a good year because of some of the new Kubernetes features that came out earlier this year. So, and then I've got the old slot machine there for the multi-arm bandit, and of course A/B testing. So this is some of the tooling, right, that we're building. So the ability from within the actual notebook, they can deploy it so that that new instance goes out, the Canary. That's going to return you this URL that you would click that's going to show you metrics. Right, so data scientists love this, right? Yeah, so they love data, they love charts, they love right, like things like this. So, right, like before, this would be they would hand it over the wall. They would have to maybe start to instrument, their Canary specially and write out. Yeah, there's one team within Netflix right now that actually does this, where they don't have this kind of feature, right? So they actually have to instrument their code to write out the predictions, and then later, they go compare the two, and it's just, they've got all these custom scripts set up, SQL scripts to compare the two, and they're writing to some rogue MySQL database that, no one knows about, that kind of thing. All right, here's the fun Netflix, like microservices here. So we'll actually show some of these in action. These would actually be right, like prediction service or the decision tree service, or that, right, like that, yeah. So basically, each service here would contain one model that you've deployed. And yeah, we'll scale it up, and yeah, I'll explain some of these numbers here in a sec. This is more for the performance, right, like geeks in the house here. For the online model training, yeah, I talked about this as new data comes in, just sort of making changes. So there's a picture of matrix factorization. Take a snapshot of that, big matrix on the left. That's your users and your really item ratings. Factor it out into the user matrix, and then the really item factor matrix. And so throughout the day with the incremental updates using gradient descent, we're changing weights on those smaller matrices. And then like recalculating like predictions, we're recalculating recommendations per user, and because we also split it out into items and then users, we can actually do item-to-item similarity, we can do user-to-user similarity, and some other fun things like that. And this is real time. We can make changes like this real time. So yeah, this is sort of a visual of the native code generation. So on the left is an actual debug statement within Spark, the Spark API. So I've created the model. I call toDebug string on that model that's been built, and it's the actual set of if statements. Can't really see it too well, and so picture the ability to just click a button and then generate, right, like Java code. This is native Java code, push out that native Java code, and now we're running at, right, like native Java speeds. We can take advantage of the JIT compiler, right, like things like that. Or picture going out to straight C++, or even creating GPU kernels that specific to, right, like the NVIDIA chips, things like that. So if you want to become a contributor, please do. That's one of the reasons I come here, is to find people interested in this kind of stuff. I think we're doing some cool stuff. So yeah, focus for next year will be performance, CPU, GPU generation. We're looking for good, right, like CUDA developers, if anyone's out there, and of course trying to find more like global contributors. So yeah, we only hire nice people, right? Yeah, that's a nice guy right there. All right, so demo time. Let's get to it. Let me just cover the four demos that, or the four concepts that I'm going to demo. So I'm going to show the Netflix microservices in action. This is one of my favorite demos. Very visual, very slick. And we'll load it up, and we'll start to scale out these services, right, with just a couple, right, like Kubernetes commands. And let's see. Yeah, we'll actually deploy, we'll generate PMML, we'll deploy it to both clouds, both directly. So there's two models of deployment, right? You can have your current cluster and just never ever tear it down, and just, right, like keep doing live updates. So that's called the mutable like deployment model, right? That's a bit scary. Right, like one thing I learned at like Netflix is the more often like you can cycle your like long-lived, right, like instances, the better, because there's just weird things that happen when these instances live for more than a few days, right? So I've turned more towards, right, like the immutable deployment model. And so what that would look like is you would generate the model in PMML, you would then commit that model into GitHub, right, let's say, and then that would trigger this workflow that would build a new Docker image. It would tag it with the like GitHub hash, right, that you got back when you committed it. And so now you can actually tie the model that's in GitHub to that Docker image. It would then deploy the Docker image out into that 1001st, right, like Canary instance that's living alongside. It would do all this. It would then return the URL to the notebook, and then you can start looking at those comparisons. Quick note about the native code generation, the way that we can take a Spark model and create the big if statement within Java. There's this project called Genino. I would encourage you guys to look at if you're interested in bytecode engineering and things like that. It was a bit of a dormant project for years. Spark actually uses this on the inside. If you guys are familiar with the way that Spark does query optimizations, it's called the Catalyst Query Optimizer. It takes your logical plan, your SQL, and rearranges the AST and does the constant folding and all that good stuff. When it's creating the physical operators, right? So the last step where it's creating the physical plan, it actually switches over to this code generation, and it's physically generating, right, like Java source code, and then it's compiling it on the fly. Yes, I'm going to show you guys a demo about how we use it, and it then caches that it like literally creates a class file, right? That gets loaded into the class loader. It's a first class citizen within the JVM. If there's, error, if it hits a stack, or if it hits, right, like an error, it's gonna dump the same stack trace it would normally dump. You can tie it back. You name the class such that you see that it's been dynamically generated. That way you can just kind of, if you see it in the logs, you can tie it back. But yeah, so they would take, let's say you're doing like a map, and a filter. It can actually fuse all three of those together as of Spark 2.0 and make one method. So from a like Java virtual machine standpoint, JVM standpoint, this is just one function call. Spark 1.6, it was doing something similar, but it was actually for a map filter. It was 3 separate functions. And to call 3 functions, or to call one function, there's all these virtual function calls you have to make, just the way the like JVM works. So by fusing those together, I think the Spark guys call it whole stage code generation. They can figure out which like operators you can actually fuse together. They're typically ones within the same stage, if you're familiar. Stage boundaries are when shuffles occur. So if you're doing joins, they can't be fused together. But if you do a series of things that can all be pipelined, you can make just one Java function. That's a pretty, and so since Spark picked it up I think about a year and a half ago, they actually changed the look of the like homepage. This was like a janky homepage before, and they actually fixed a bunch of open like pull requests or like Jira's. People were starting to submit pull requests. Some of the Spark guys started getting involved because they needed. They chose this. There's a few different ways to generate source code. The Spark guys found that this was actually the best in terms of IDE support. So when you're actually developing and you create this inside of your tests and things like that, you can actually start to drill in it's a first-class citizen within Eclipse or the IntelliJ or whatever, right? So that was, from a development standpoint, this was better. The other option would have been something called quasi-quotes within Scala. It's one of the obscure features of Scala that I really don't know too much about, so I'm not going to comment further. TensorFlow Serving, I'm going to have to talk to this. This demo's a bit busted right now. So I had upgraded to the latest TensorFlow, and something is broken. So, but the cool thing is I'll talk about how it works. Actually, I'll just talk about it real quick. TensorFlow Serving, so this was a first-class citizen when TensorFlow first came out, last November, right? TensorFlow Serving really sort of highlighted this serving layer, this like prediction layer. So there's some cool features here. They actually, does this work? Oh, yeah. Yeah, so they actually support, right now they support just kind of the basics. When you start up TensorFlow Serving, which is what's actually serving up these models, so you would call into TensorFlow Serving, you would pass it like an image, you would get back the classification, the top 5. This is a panda. This is an organ. This is whatever. So when you start it up, you point TensorFlow Serving to a parent directory. And then each new model that you come up with in your training cycle within like Jupyter, you actually just push it underneath that parent directory. And you have to version it such that the version number is higher. And there's this constant watcher. It's pretty basic stuff, but yeah, this actually works pretty well. And it'll actually flip that new version in. There's a few different version policies. So the most basic one is sort of let the current version of the model drain if there's any classifications that are in flight, and then flip it over. I think out of the box there's one where you can have them running at the same time, and it's just like load balancing between the two. You can build your own versions. They've done a pretty good job of sort of making all of these different pieces their own abstractions so you can extend. One other cool thing too is that so picture multiple devices. Say that right, like we all pull out our phones right now and want to send a picture in to get classified, right? Like tell me if yeah, this is a particular kind of flower or whatever. So if we all do this, so TensorFlow Serving has the ability to actually batch up, right, like multiple client requests, so from separate people that don't know about each other. It can do these matrix multiplies by sort of putting them edge to edge into one gigantic right, like matrix. It's all zeros everywhere else, passes that whole thing in once, and then can right, like pull it back out, parse out the results, and send it to all the separate clients. So yeah, this is pretty powerful stuff. When you start it up, you can turn on that feature and say to do this every 5 milliseconds or 10 milliseconds, whatever your latencies are, your tolerance is. So I'll show too how we can do that with Java and Spark with some of the Netflix open source. So yeah, pretty cool stuff. Oh, and then, yeah, this is supposed to come later. All right, so let me show the demo. I just said thank you for choosing me, but yeah, don't leave yet, because the best part's coming. All right, it's still on my screen here. Just double check I ran it real quick. Want to make sure there's no errors. Okay, so let me zoom in. Okay, so first things first, so this is Jupyter Notebook. We're using all Python here. I've sort of interspersed some scripts. These scripts are pretty long named because this is going to become its own sort of, yeah, the like code name for this project, it's called Data Sticks, which is kind of a funny name that my old employer, I think, is probably going to sue me over. So I should probably change the name, right, like Databricks. But yeah, so these are scripts that actually interact with Kubernetes and sort of hide all the low-level right, like Kubernetes calls. But like they're actually not that bad. And then I've got a couple just straight-up Kubernetes calls here. So let's just go down the line and I'll explain what I'm doing. There's 3 different clusters that I'm going to talk about. There's the sort of training cluster, which is what Jupyter is running on. That's where Spark lives. That's where, Redis and Elasticsearch and all those. So actually, let's just kind of show you here. So I switched over to the training cluster. Here's a view from like Kubernetes standpoint. This is all the tools running. So we got things like the Hive Metastore and MySQL and Presto. Spark's the big one. Spark's the one that we want to work with today. Okay, so that's kind of the command line looking version. Let me show you guys the actual Kubernetes pretty version. So I have a better view of it right here. Let me refresh. All right, so these are all the pods. Pod is a term within Kubernetes. It's sort of it's a logical container of Docker containers. The way I'm currently using Kubernetes, I have 1 Docker container per pod. So just think of pod and Docker container as the same thing. In fact, if I click over to just containers, it should be fine. Okay, so here's where we actually, so this is kind of a visual. This is this tool, WeaveScope. I was at a conference or meetup or something, and I saw someone using this. The name of the company is Weaveworks, and I think they're like a Kubernetes native company. Pretty much all of their tooling is around Kubernetes. This particular tool, this is totally open source, so, and it's really slick. You can actually crack open Spark Worker. So here's the Spark master connected. This is kind of showing which pieces interact with each other. Of course, Jupyter, it's putting socket level tracers between Docker containers. So that's how it knows that Jupyter talks to the Spark master and the Spark Worker talk to each other. So I can actually click in here and check this out. I can not just look at the logs, I can actually hop on straight into this Docker container. This is huge. I can go into the Spark directory here. I can look at the logs. Yeah, if I can't zoom in too far, but so I'm physically inside the Docker container. This has completely changed my workflow. You can do this with Kubernetes. There's this really long, janky like command to do it, and I tend to always type it wrong. Right, like typing KUBECTL is one of the hardest things on the keyboard. It's like really awkward. Like I was thinking about switching over to the Dvorak keyboard, maybe to make it simpler. But yeah, this is really nice. I can click in and check out each of these tools. So that's the one cluster. That's sort of what we're going to be interacting with. And now when we're done building the model, we're going to deploy it to both a Google cluster and what I'm calling prediction cluster, the sort of microservices cluster, right? So here I can actually click. Right now there's one service out there listening. I can actually scale up this service too. This is something I didn't show with the Spark worker, but I can actually just click plus, right? Like right from here, which is just basically doing the kubectl commands like beneath the covers. But yeah, this is really cool. And this is showing me, zoom in a little bit, this is basically showing me top, specific to this Docker container. So I can see which processes are using the most memory. The other thing, if I actually want to look at the physical hosts, so I've got one, let's see, this is Amazon. I've got one of the the R32XL EC2 instance out there. If I go back to the training, I'm going to click hosts here. I have actually two R32XLs, and that's because all of those tools actually require more physical, right, like underlying hardware than just the prediction services. So let's see, here's the Google one, same thing as the Amazon. Click it right here. So these are all live running out there right now. Okay, let's go back to the notebook. So I already showed the training cluster. I already showed prediction cluster visually. Okay, so let's. Oh, and then if I show you guys, so I showed you visually the Spark worker. There's just one Spark worker right here. So I can actually. So here I'm just going to switch over to the training cluster. I can run this command to actually scale out. This is hiding the kubectl command, but I'm actually, with one command, physically scaling out Spark worker. So here's the admin for Spark. I click refresh. Yes, I just added 4 more. So I told it I want 5 Spark workers, and that took seconds to spin up 4 more Docker containers with 4 cores, 4 gigs of RAM, that kind of thing. Some of you might be asking, well, yeah, are you oversubscribing those 2 EC2 instances? Because the R32XLs have 8 cores each and 50 or 60 gigs each, 60 gigs. And yes, it's possible to do that. You can configure, with Kubernetes, when you, on a per Docker container or per pod basis, you can say, only allocate, so like when I said, give me 4 more, I could tell it to sort of try to fit 4 more in. If it can't find it, then fail. I could start to prioritize. So if I do get into the situation where I've created more Docker containers, what's going to happen is it's going to operate just like the Linux killer, it's called, where if you start to have too many Java process or just rather general processes on Linux, it's going to start to shoot them in the head and drop things randomly. So you can get around that with proper Kubernetes, right, like capacity planning and tags that you put on these things and say, don't kill the Spark master, for example. That's really bad. First, try to kill the Spark worker, right, yeah. So there's different ways to configure Kubernetes like that. Also, too, I pointed out the nodes within. Oh, so now, yeah, over here I should see actually 5. Visually, there's 5 Spark workers. 1, 2, 3, 4, 5. So the physical hosts, right? So I said I've got 2 hosts on this training cluster. you can actually pin Docker containers to specific hosts, right? Like based on whether or not they have GPUs, right? Like different characteristics, whether or not they have a fast disk or more memory, things like that. So it kind of gives hints to the scheduler, the Kubernetes scheduler, to say, don't run this container, not unless it has GPUs, and then you would be running a special Docker container that has, holes, right, like poked into it for the different GPU devices. Okay, so now that we've scaled it out, the Spark cluster, we looked at the Spark admin, showed you guys that. Within seconds, it showed up. So we're using Spark 2.0 here, so we've got the Spark session, not Spark context. Here, I've created this bucket of just kind of common data sets that I use for demos called Datapalooza. And we're going to use the old famous R census data set. What we're going to do is build a decision tree such that we're going to predict income based on all the other features in this data set. So, work class, age, marital status, that kind of thing. So we're using our formula within Spark. We're trying to build this decision tree. We're building up a Spark ML pipeline, right? So now this is a pretty big deal because you always want to think about pipelines here because there's feature transformers and there's standardization, right, like normalization. There's all these things that happen during training that when you go to deploy the model, right, like has to stay with it, or else that, right, like data coming in is just going to get misclassified. And so not until Spark 2.0 was there good full, right, like, or 99.5% full PySpark support for the ML pipelines. There's a few small ones missing, but things like one-hot encoders and that kind of stuff, like that has to travel with the entire pipeline, not just during training, but also when it's pushed out into the live serving. So real quick, here's kind of a similar tree to what I had in that Zeppelin notebook. This is actually, I'm inspecting the pipeline. I'm saying the second stage. This is 0 indexed, so second stage, which is this classifier. After we fit this model, pull out that second classifier. I call the two like debug string. This actually prints out the big if statement. And here, I was just doing a little debugging earlier. Here's where we're actually converting it to PMML. We're using this this library. It's the JPMML hyphen Spark ML project. So it's been working pretty good so far. So here's the big ugly PMML. And so here's an example of the mutable. So we've generated the PMML, converted it to bytes, which are nice and friendly for the operation that we're about to do. And then we're calling this, so this is a live REST endpoint that's running, this is the Amazon prediction service, so let me see, it would be this guy. Oops, is that the wrong one? Oh, yeah, it's just showing too much here. Application containers, okay. Yeah, so it's physically this Docker container. We're gonna actually push out the live model in PMML. Within memory, it's flipping, and it's taking whatever was in there before, just getting rid of it, and it's gonna replace it with this new PMML. I got response 200, that's good. And now we're actually gonna pass in this JSON document with age and work class and all these things. We wanna predict the income. So this endpoint was called update PMML. This is something you would typically lock down, like you don't want people, the like outside world to actually do this. And here, this is what the outside world would be calling, from their devices or from, right, like whatever. So this is the evaluate. We're trying to predict the income, so let's run it. Here's the results. comes back for the particular input that I gave it. There's a, 95.6% probability that it's less than 50K, and 0.04% that it's greater than 50K. Okay, and so so now this is the immutable model. This is the sort of safer, there's one big advantage. In fact, I was talking to some of the OpenAI folks who are like using a lot of this stuff, using like Kubernetes and like sort of building this kind of thing. They found that people actually like this model better because this is a lot faster. Oh, I have 2 minutos. Okay. So because for like the immutable model, this is a little bit different. You have to save it out to disk or somehow get it into GitHub, which would then trigger this workflow, either using something like Airflow or maybe Jenkins is what I see most commonly. Starting to see a little bit more of the Airflow. And then it kind of comes around and then notifies you, when it's done doing its thing and it's been deployed as a canary. But I still like that model better because you have a canary that's running alongside the existing. You aren't actually mutating the existing cluster, and you could roll back very quickly without having to, call, like fire off another call to change the model back. All right, so let me do one. This is the fun one here. Probably won't get a chance to show you guys the code gen, but I could show you real quick the code for the code gen. But I do want to show, all right, Spark. Yes, all this code is in the repo. You can look at all this. Production, code gen. So let's say, I'm taking this from where I'm physically creating source code. This is just for like demo purposes. I would be using Genino to actually create the source code. And then here, I'm doing the same thing. I'm pushing it out and calling update source. So before I was calling update PMML. And when this service gets that new Java source code, it actually compiles it on the fly, like using Genino, and then registers it, like caches it. It's now part of the JVM, and then all subsequent like requests that come in. So here, my main logic is the string I'm passing in equal to 21619? And I'm going to update the source, and then now I'm going, so I updated it. Here, wait. That's the code 21619. Here I'm going to update it. So inside the VM, it's actually swapping the source code, compiling it. And here I'm doing the evaluate. This is a simple get call. Here's the argument I'm passing in. So let's actually change this argument. Oh, no, so even cooler, let's keep that the same. And let's change this. So the result there was true. It is 21619. Here, the if statement is checking if it's 21620. Here I'm pushing out the code, update source, I got back 200. I'm passing the same 21619, and I get false. Cool? And then the very last thing, so this is my favorite part. We're actually going to load test, let's see. So what I'm doing here is I've created a Docker container that has JMeter installed and has the endpoints all set up and has configuration. So when this container starts up, it's actually going to start pounding these two services, both in Google and in Amazon. And there's one side effect I didn't realize when I was putting this together, where I actually noticed. Oh, one sec here. Let me add one more. I actually noticed Google was about twice as fast. And I don't have formal benchmarks or anything like that. I'm not going to make a big deal out of it. And people get all bent out of shape with benchmarks. But like literally the time for the prediction was it was twice as fast. see if I can get, there's traffic being sent in, but there's one thing I gotta, come on. Demo. All right, let me just add another. So here, I'm actually scaling out. I'm getting it up to 2 prediction services on each Google and within Amazon. These take like a second or two to update, but and I can continue to add more of the load test containers, and it's going to just keep pounding, and it's going to be an additive load onto these things. So there we go. Oh wait, that's the. So this should register as 2 here in a sec. Once, yeah, these prediction services. Okay, there we go. Alphabetical. Thread pools, alphabetical. Yeah, so here, this is the Google version. And let me show the Amazon version here. So this is the actual prediction time. So this is so this is how fast is this service, right, taking in the input and then going through the PMML, right, that tree, and then scoring it, and then returning it back to the, so right now the load's pretty minimal, but it stabilizes at about, let's see, for the 90th percentile, I believe it's like 2 seconds on Google, or sorry, 2 like milliseconds, and then 4 or 5 milliseconds on Amazon. And like when I say these are similar instances, I'm talking about price. So, picture a day where you can actually start to shift traffic over, right, like depending on price. So maybe you had spot instances within Amazon, suddenly all those spot instances go, you're now back to the demand instances, it's now per request, per like prediction request, that price has gone up within Amazon, let's shift back over to Google, right? So this is pretty low load, so let's actually, I'm going to run just a raw kube command here. This is how you would scale. I'd say replicas equals 4, and the replication controller is called load test. Boom. This is some of the commands that I'm just hiding behind these scripts. But so now this is saying we've scaled it up. If I do get pod, I should see 4 of the load tests. And these come up pretty quickly, so we should actually start seeing traffic go up pretty fast here. Yeah. So green is good. These are circuit breakers, meaning if things get kind of bunched up, we'll actually open up a circuit. This is all Netflix code. That will let things drain, and it starts to return fallbacks. So a good prediction case, or like recommendations case, if this service gets bunched up, I can start actually to return just sort of global, top 10 recommendations, top 10 movies, top 10, right, like whatever. So, cool. Yeah, is that it? Any questions? If we have time for questions? Yeah, just find me later. Yeah, I'll be here all day.
Sorry, Chris, I have to apologize. Only a colleague of the organization let me know that I was 10 minutes late. So I think all in all, you got the duration of the very packed talk. Only one question, please, before we move on.
Only one question.
Yeah? Okay, fine. Chris will be at a workshop later.
Yeah.
Eventually. So thank you very much, Chris.
Right on. Thank you.
Okay, so the next session will be by Amparo Alonso and David Martinez. They are both old friends of Big Data Spain. In fact, I think I can say that Amparo is a member of the technical reviewing committee of the conference, so it's a huge help for us. This is a double whammy. 2 different talks in a single session, so it's approximately 20 minutes each. 20 minutes Amparo, 20 minutes David. Thank you.